Hey guys, it's William again from Terra. And today we're going to be building off our previous episode where we built a small little toolkit with a Python SDK. We're going to be building on top of that to create another toolkit that allows us to interact with CW20 token contracts on the Terra blockchain. So we'll do a little bit of a deep dive into CW20s and we'll basically be launching our own on the testnet. So let's go over to the whiteboard where I'll go over today's lesson plan. So the first thing we're going to do is, we're going to launch our own CW20 locally with local Terra. So with local Terra. And then we're going to be using the TerraSwap variant of CW20. So CW20 is actually a token standard for a generic fungible token that is functionally equivalent to the ERC20 standard on Ethereum. So there are many variants of the CW20 that are possible. The most popular right now is the one that is created by TerraSwap. So we're going to be using the one from TerraSwap because we want to be interacting with TerraSwap later. So after we have our CW20 contract loaded up, so stored, instantiated, we need to test it by playing around with the various functions of it. So we're going to be storing it, store code, instantiate, and let's try executing a mint operation. So this will make sure that the functions that we create work. And then finally, let's move on to the testnet so that other people can play with our CW20 contracts. Okay, so this is the lesson plan for today. All right, let's head over to VS Code. All right, so okay, let's talk about. So this is where we left off yesterday with our mini toolkit. The first thing I'm going to do is just get the CW20 token contract from the TerraSwap repository. So I'm going to clone the TerraSwap repository. Oh, that should contain all the contract code. And now we have it right here. And should be under artifacts for the WASM binary. So let's move that one into our test contract scripts. All right, so let's store the code and instantiate our own CW20 contract. Okay, so instead of storing test contract, we'll be doing TerraSwap token. Instead of doing this one, we need the TerraSwap init message. So for the token init message, it's probably going to be under packages, TerraSwap, source, token. Okay, this is the format of the init message. All right. So we don't have to do the optional ones, but we're going to basically have to do this mint one later. Let's start off with the basic init message without the optional ones. So we need a name, symbol, and initial balances. Okay, so the name, let's just call this my token, my Terra token. And the symbol has to be some 3 letters, MTT. And what was the other one? Decimals. I'm just going to use the mirrors convention and use 6. That means that one single unit of this represents 1/1,000,000th of that token. And initial balances, which is going to be a vector or an array of these type of pairs. So you need to do the address and just use the deployer for now. And then amount. Let's do 1,000, and we set the decimals to 6. So then these 6 represent 1. So this would be 1,000. Okay, so we have that contract address, and let's instead of get count, I believe that they had some query messages where we can query the balance. So balance and address, right? So this is the query message to use, and we go back and we do balance and address and deployer.key.ackaddress. Okay, so let's try running this. But first, let's see if our Docker is set up. So let's launch up localterra. Wait for that to load, and we should be able to run Python 3 contract.py. Oh, it's not up yet. Takes a while sometimes. Okay, I think we should be good now. Okay, let's see. Sometimes we get these errors. Let's try this. I think it's right here. Let's print the results. Something helpful is you can just start printing the results. I believe this one is in... Let's try this. Okay, initial balances. Failed to execute message. Okay, so it's actually initial balances, not initial balance. Okay. All right, so we find that it works. And let's try doing a simple transfer function. So now we can have the deployer send some tokens to somebody else, right? So let's do, so let's execute contract, and we want to execute from the deployer, and we want to execute the contract address, and the execute message is simply transfer, and then the only things we need to supply are the recipient and amount. So I'm going to do 500, and the recipient will be let's just take another one, like test2. Okay, so here the recipient will be test2, or account2.key.ackaddress. We're going to execute that contract. We're going to print, and then we're going to print the final balances of both. Okay, so we both should expect to see 500 in each account for each balance. All right, so this works. All right, now let's talk about how to mint, because we have this token, but how can we issue a mint operation? So we start with the we basically allow a minter using this minter response. Not sure what the minter response looks like. We'll have to go into the CosmWasm code. Let's see, CW20 GitHub. I think in CosmWasm Plus. Let's check out the packages, CW20, and I think it will be in state. Let's see, message, query. Yes, minter response. Here we go. So basically, we just have a minter and an optional cap. So we can basically forgo the cap for now, but if you want to, you can add it. Let's go back to our code. So we have the minter response, which is the mint, and then put in minter, and the person who is able to mint it is the deployer.key.ack address. So our deployer. Okay. All right. So now so what we want to do is after we sent it, we want to mint again another 500. So let's do that. So instead of that, I'm just doing mint. And how does the mint look like? What does the mint operation look like? Here we go. So we can actually mint to a recipient, but the recipient should be ourselves, and the amount is the number of tokens that we want to mint. So yes, I think it's the exact same parameters instead of transfer. So let's try this out. All right. Well, actually I gave the account to the balance, so that's why it has 100 million units, or 1,000 or a billion units. Okay, so now we set up our own token. Let's see if we can do this on the testnet. So what I want to do is to basically replace any local Terras with the LCD client. So instead of local Terra, let's do LCD LCD client, and instead of LT, well, I'll keep it as LT so we don't have to replace too much stuff. So the URL is tequila.lcd.terra.dev, and the chain ID is tequila0004. Okay, now we need basic accounts here, so we also need we need a mnemonic key, and so let's just before we execute anything, let's just make a mnemonic key. So let's see. So deployer's key will be a new mnemonic key, and account 2 will also be a new mnemonic key. Here, deployer key, and account 2 key. This should help with it. And then let me just print out their mnemonics, so then I can give them some funds. Okay. Now, let me just run the code quickly. Let's see. Okay, I just ran the code quickly, and it will. So I will just figure out what. Oh, I need their mnemonics. I needed their account address, so I can give it funds. And I needed the mnemonics too. Just to be helpful. Okay. Okay, so we have 1 and 2. Let's go to the faucet and give ourselves some tokens on tequila. Oop. Okay. I will give myself some Luna. Okay, now I have 1,000 Luna. Be more than enough. Okay. All right. So we have money now, and we have the mnemonic. I can just tell this to load from this mnemonic. Okay, and use this mnemonic as well. right here. Okay, we have both mnemonics. Now we don't need this, and we can just set deployer lt.wallet of deployer key .wallet of deployer key account 2 key. Okay, now we have those as wallets, and this should work on Tequila now. So let's try this. Now it won't be as quick because we have to store these tokens, but you'll see that it will work. So let's just try it right now. So now we're just testing this on Tequila. Okay, so every time we do this, we have to update the counter. So we need to update the sequence because it's running too fast. Right, so we should be updating the sequence for each of them as sequence, and then we just put the sequence here. Sequence and account number. Okay, so the first thing we need to do is get the sequence. So sequence equals to lt.auth.account info. And I'm going to get the account info of deployer key.ac address. Right, just make sure this works. I think it's .sequence. Let's try this. Oh. .sequence. Okay. Works. Now we just put in sequence. That's the first sequence. And then we use the next sequence, +1. Sequence +2. Sequence +3. Okay, I think this should work now. Now we have the TX hash. Let's see. Somewhere. Ah, yes, we put this in the wrong place. Sequence equals sequence here. Let's try this again. So there you have it. It was a little bit indirect because of all the errors, but well, we resolved them very quickly. Let's see if, yep. So there we have it. This is on the testnet, and we can check. We can check on the Finder. On the testnet. Yes, there we have it. This is our init message. And there we go. And we have a contract address here. And this is our token. Right. With the correct minter and everything. And there we go. And that's how you launch your own token with a with the Python toolkit that we made yesterday. All right. Thank you.